Properties of logarithmic functions. If you don't remember these rules, pause the video, write these all down because you need to pretty much have these memorized. We're going to be using them. Alright, got it? Moving on. Alright, so we have 3 examples here where we're going to expand, which means we're going to break them into more than one log. I'll do the first couple and then I'll let you do one on your own. Alright, so first off, since I see them multiplied together, I'm going to break them up into added logs. So we're going to take the log of 8 plus the log of x plus the log of y to the 4th. With the log of y to the 4th, we need to move the exponent out to the front as well. I'm missing all sorts of letters. For the second one, we have division, we have some multiplication, we have a square root. So copy down your answer to the first one. Let me erase and give myself some room. Alright, so what I'm going to do here first off is start with rewriting the square root as an exponent. So then I have the natural log of x squared plus 5 to the 1/2 minus the natural log of x. This is all one big. And so then I'm going to pull the exponent out to the front. I can't go any further, even though you see addition in there. That would really have to be the natural log of something plus the natural log of something else to combine it. Or they would have to be multiplied so I can expand them. Okay, try the last one on your own. Okay, so change of base formula. You've probably learned this before, but basically we want to change it so that we can plug this into the calculator by making a equal to 10. This is the original. So to help you kind of memorize it, the x part, or whatever's there, goes on top. B part goes at the bottom. So copy that down and then let's try some examples. So to rewrite as common logs, I'm going to take the change of base formula. So we're going to have log base 10 of 16 over log base 10 of 3, and then I can plug that into the calculator. Common log of 10, common log of 6. I can now plug that into the calculator. I want you to try this last one on your own. Plug it into the calculator once you get into common log form, and then give me the answer. So evaluate this one. So the graph of the the logarithmic function, it looks like it kind of starts right at this point. It's a tricky graph. It actually has a vertical asymptote here. If you remember, since this is the inverse of an exponential functions had a horizontal asymptote at 0. So when we flip over y equals x, we get our vertical asymptote at x equals 0. So this means that the domain is going to be, we're not going to equal 0, so curved brackets up to infinity. Range, even though it doesn't look like it, it's negative infinity to positive infinity. Asymptotes we covered. Intercepts, we have an x-intercept. So if we have log base b of 0, of x equals 0, so in exponential form, that's b to the 0 equals x. Well, anything to the 0th is 1, so we get an x-intercept at 1. And so when we do transformations, something that you're going to need to look at is that the log base, to put this into a calculator, log base b of x, using the common logs, is log of x over log of b. So since we're dividing by something that's really a constant here, that denominator, we're going to get a vertical stretch or compression. So if so as the b value changes, we're going to get compressions that start flattening out our curve a little bit here, or we might get a stretch. You'll be able to look at the graph by using the change of base. Also keep in mind that if we have something like log base b of x minus h, if we have a subtraction, we're going to move to the right. If it's addition, we're going to move to the left. And then, of course, you could have vertical shifts by changing a value outside. All right, that's about it. Make sure you tried both of the try on your own and have written down any problems that you might have.